Hello, everybody. Today we'll start Programming for Engineers course, Comp 215. We'll start by Chapter 1, Introduction to Computers and Python. The outlines of this lecture will be Introduction to Computers, Elements of a Computer System, Programming Paradigm, and some history of programming languages. First, this course adopts a top-down approach to the subject. And so far, we have taken a computer as a black box. But it's time to look inside the box. What happened inside the computer? We'll start by looking at different parts of the component of the computer, then go to the programming languages. Later, we'll learn the basics of Python on the next lecture. Okay? As a fast review about elements of a computer system, maybe you took this in Programming 1, in course Programming 1, maybe. So elements of a computer system divided by two parts, hardware part and software part. As you know, hardware part has many components, hardware components inside, starting by motherboard. The motherboard will be installed on it every components in the computer, starting by motherboard. Then we put the CPU, the processor inside it. Then we put here the RAM, memory. Then we put on external PCI slots here, external sound card or modem or VGA here, and so on and so on and so on. And we have optical drive, CD-ROM, DVD-ROM, Blu-ray, and others. Also, we have normal hard disk, and today we have SSD hard disk, or we have NVMe hard disk. Also, above the CPU, because the CPU will be very hot, very, very hot, so we put above the CPU the heat sink with the fan, aluminum plus fans, okay, to cool down the CPU. On all the computers was using floppy disk. Today we don't have floppy disk. We have alternative like flash memory, USB flash memory, and so on. In the case, we have inside it, of course, fan, one fan or two fan, and of course, to operate all these components, we need power supply. So power supply will convert the AC power to 120 volt, the AC power from your home to 120 volt, converted to DC power from AC to DC, from AC power to 120 volt to DC power, DC volt, like for the motherboard 5 volts, for the RAM 3.3 volt, from the DVD-ROM or hard disk or fans will be 12 volt. So the power supply has many outputs DC. 0 volt, of course, 3.3 volts for RAMs, and some VGA. Some VGA needs also 3.3 volts. Also, we have 5 volts for the motherboard and 12 volt for mechanical parts. For mechanical parts means for fans, old hard disk, and optical drive. Okay. Now, do you have any question for this? Do you have any question for this slide? Good.
No.
So now we'll go to the software. As you know, the software also decomposed for 3 parts: operating system, like Windows, iOS, and so on; applications, softwares, applications like Word, Excel, PowerPoint, and so on, Photoshop, and so on, games, and so on. Also, the programming languages. So software also will be decomposed to three categories. Now, the application software, which is any application you have, like Microsoft Office, AutoCAD, Photoshop, games, WhatsApp, Facebook, and. So this is called application software. So the user will use this application software, one of them, any application software. Then the operating system software, the operating system like Windows, Linux, Mac OS, iOS, Android, and so on, this operating system acts as an interference or interface between the application software and the hardware system. Okay, so the user will use an application software, any application. You told them, I want this or this or this, then this application will be bridged to the hardware via operating system software. Okay, so operating system software will act as interface between the application programs, games, and so on, and the hardware components. Okay, this is clear. Good. Now, about programming languages are, we have machine language, an old programming language, starting by machine language or machine code. It's a collection of bits that the computer reads and interprets. So before, we use machine language like 0110, like switches. We have switches, many switches. I want to enter any syntax or command to the hardware, so I write it or I put it 0011, 0101, whatever. So it's series of switches. This is machine language. Later, they invent a low-level programming language. Low-level programming language, it's assembly language, ASM, assembly language. Also, it's hard. It's not easy like today Python. Okay, it's hard language. You can use some English commands, but still hard. Inside any language, we have something like assembler. Assemblers convert the assembly language into machine language. So to convert this syntax, some English word inside assembly language to the machine language, we need assembler. We have also something called interpreter. Interpreter also, it's like engine or libraries, converts just one statement at a time of the high level language program into machine code or machine language, like JavaScript and Python, C. Okay, so interpreter, it's similar to JavaScript and Python. So Python, it's not compiler. C is compiler. Python is not compiler. It's interpreter programming language. So Python, it's interpreter programming language. The interpreter inside Python will convert one syntax by one syntax, one line by one line. Okay, statement by statement. If an error occurred, so the error will be halt or paused for this line to be corrected. Okay, so it's slower for checking error. It's slower than compiler. And we have compiler, scans the entire programs and converts the whole high-level language into machine code like C, C++, and Java. So I will repeat again. What is the difference between compiler and interpreter? Okay, like C and C++ and Java, the compiler for checking for error, when you convert your code, your English code, to the machine code, okay, in the compiler, they scan all the code, your codes, and state your errors, the errors inside your code. So first step, write your code. Second step, checking your code for errors. In compiler, when you're checking errors, your code for errors, will list you lot of errors in this line, that line, and that line. So you can correct them, update your code, save it, and run again. Whereas it's faster than interpreter. For checking for errors, compiler is faster. Okay, so inside interpreter like Python, when you run checking for errors in Python, the interpreter will checking line by line, statement by statement. If an error occurred, will stop and state for you that is error. You need to update it, correct it, then run again, run again, run again. If you have lots of errors, of course, compilers faster than interpreter. But for running programs, if you write code in Python or in C without errors, the interpreter is faster than compiler. For running, for execution file, to convert it to the machine code and execution file to be run your application. So Python or interpreter, not only Python, the interpreter is faster than compiler, but is slower when checking for errors. Okay, you got the ideas? Any question here? Good.
دكتور بس امتى بتكون ابطأ؟
على checking for errors. لما نعمل checking
أوكي.
for errors، الانتربريتر بطيء لانه بيعمل checking for errors line by line. بيعمل checking
ماشي.
اول سطر، اذا في ايرور بوقف بدك تصلحه، ترجع تعمل سيف، ترجع تعمل ران، برجع بصلح الثاني checking. فاذا عندك اخطاء كثير، اذا عندكم اخطاء كثير بالكودز كاتبين لنقول 50 لاينز 50 سطر، وكل سطر في خطا، الانتربريتر بده يوقفك 50 مره، بكل سطر بوقفك وبقول لك في غلط، بتصلحه، برجع بوقفك بالسطر الثاني، بصلحه، بتصلحه، برجع بالسطر الثالث والرابع. يعني اذا في عندك اخطاء كثير، انتربريتر كثير بطيء. كومبايلر لا، اذا عندك بكل اللاينز اخطاء، كومبايلر بون تايم بيقول لك وين اخطائك بكل اللاينز ات ذا سيم تايم، بتصلحهم كلهم مع بعضهم وبترجع تعمل له ران. بالشيكينج فور ايرورز، للشيكينج فور ايرورز الكومبايلر اسرع من الانتربريتر. بينما after that اذا ما عندك اخطاء، no errors in your codes, interpreter is faster than compiler. Okay?
تمام دكتور، thank you.
Good. Now we have different paradigm. Style. Paradigm means style. Who style? A programming paradigm is a programming style. أسلوب. How to write. Your way to problem solving. How to think. What is your algorithm? Okay, this is called the style. So paradigm, we have different paradigm in any programming language. Okay, we have programming paradigm. We have imperative and declarative. Imperative means you have a fixed algorithm, fixed steps to do. Step 1, I want to do this. Step 2, I want to do that. Step 3, step 4. So it's in details. Imperative means you write your code in a procedural way. Procedural way, step 1, step 2, step 3, step 4, step 5. Okay, like you did in C. Also, Python has this function, this paradigm. Okay, so procedures language is like C, Pascal, Python. Also, we have object-oriented. If you get OOP course, you will use Java or C++. So C++, Java is object-oriented. Also, it's imperative language. Also, as you can see, we have Python. So Python is procedural and object-oriented, also functionally. Okay, so the first part for step 1, step 2, step 3 in details structures, in details writing a syntax called imperative. And we have declarative paradigm. Declarative paradigm like logical functions or logical thinking, like language called Lisp. We have a language called Lisp used for logical thinking. Okay. In 2014, we stopped in Beirut Arab University teach Lisp. Okay. In the old days, in the old years, we teach Lisp inside Beirut Arab University. Okay. But 2014 and till now, we stopped Lisp. Okay. So it's logical thinking language. It's like English language. It's like pseudocode, similar to pseudocode. Write in English statements, then converted to the machine code. Also, we have functional language. Functional language like Prolog. Okay, in the same course we teach Lisp and the Prolog. Okay, in the same course. In all years. Okay, before 2014, Lisp and Prolog as the same course on algorithm course. Okay, now the functional will be today is Python. So as you can see, Python at the same time has different style. You can use it as functional language, and you can use it as a procedural language or as OOP language. So this is why Python is dominate. That's why Python is dominate on all other programming language, because you can use it as functional, you can use it as OP, also you can use it as a procedural. So that's why Python is very dominant right now in these years. Okay. Okay, so we will learn in this course Python. Any question for this slide? Good. Now, what is Python? As usually, all the programming language used in computer engineering are C, C++, Java, and now becomes Python. Okay. Python is an OP, object-oriented scripting language, that was released in 91, but it's not famous in that year. Starting 1991, but it's not very famous at that year. It was developed by Judo of the National Research Institute for Mathematical and Computer Science in Amsterdam. So it's from Amsterdam, the first issues or version for Python. So Python has rapidly become one of the world's most popular programming languages. It's now particularly popular for educational and scientific computing. They use Python in educational programming language and for scientific. Also, it's an open source programming language. It's free. So Python is free, not like others. Not like other programming languages like Microsoft Visual C++, Visual Basics, and so on, ASP, and so on and so on. So it's a free programming language. It's easier to learn than other languages like C, C++, C#, and Java. It's simpler, easier, simpler. We have built-in functions, we can use it directly. So it's easier. It supports popular programming paradigm, procedural, functional, and OOP, object-oriented, as we said before. It enhances developer productivity with extensive standard libraries. We have in Python extensive libraries. We have many libraries and thousands of third-party open libraries. Thousands. Okay, so we have many libraries. So programmers can write code faster and perform complex tasks with minimal code. Just use any built-in function or libraries. You can use it directly. No need to reinvent the wheel. Just use existing libraries or functions. Why we want to use Python? Because it simplifies concurrent programming. Concurrent programming means parallel programming. You can running or execute your programs in parallel way. There is some libraries, some code inside Python that your code can be running in parallel for parallel CPU. In C, it's very hard. Okay, in C++ we have. Okay, in Java we have parallel. So because we can use it as parallel programming language, this is advantage. Also, we can use extensive job market, because right now, if you search for a job, for programming job or software engineer jobs inside US, Europe, or all the world, every job description include Python. You know Python, we will hire you. Okay, so Python is right now booming in all companies. Also, the Python jobs are among the highest paid of all programming jobs. Also, when you search by Google, you can see that top salaries in software engineer is Python. Where we can use Python? Where? Of course, you can use Python in applications with a massive number of users, which other language cannot, like C, C++ cannot be programmed for massive number of users on the global internet, such as Dropbox, YouTube, Reddit, Instagram, and Quora, and also others. So these platforms or these websites, as you can see, using Python. YouTube itself, the code of YouTube is Python. Okay. Of course, Python can be used as web development, like Django and Flask. They use Python. Also YouTube, they use Python. In the game development, so you can use Python in the game. There are libraries such as PySol or Pygame to create games, such these games, Disney Town, Vega, Tetris, etc., etc., etc. So Python, you can create a game, and we will make a game at the end of the course. At the end of the course, we want to create a small application and small games. Of course, for the highest peak or topics in the world is machine learning and artificial intelligence. So these topics becomes nowadays booming. So they use also creating algorithm which makes the computer learn by itself using the libraries such as pandas and NumPy and so many others. Okay. Also, we use Python in artificial intelligence and machine learning, which are hot topics in these days, using Python. Also in data science and data visualization, like data is money. If you know how to extract relevant information which can help you take calculated risk and increase the profit. So in statistical website, بالاحصائيات بالاناليسيس بالريبورتس، البايثون بيعمل ريبورتس، بيعمل statistic، بيشتغل كماثيماتيكال ابلكيشن. اوكي، أسرع من غير البرامج. Okay, so you can analyze the data from any website, any program to save money. So this is very important. Also, we have GUI, graphical user interface. We use Python to program desktop application like Tkinter, library that can be used to develop user interface. We will use this library after midterm. Okay, after midterm we'll begin GUI, graphical user interface, Tkinter. We'll make some application and some game using Tkinter. Also in the web applications, so it pulls a large amount of data from websites, which can then be helpful in various real-world processes such as the price comparison, as we said before, data science and data visualization, jobs, listening, research and development, and much more. So we can use Python in everywhere, everything. Also in business applications, such as e-commerce, ERP, and many more. Platforms such as Triton is available to develop such business application. Like in Alibaba, Amazon.com, Alibaba.com, and so on, they use inside Python. Of course, you can use it also in audio and video applications, such as Time Player, CPlay, Python, using Python. Also, we can use CAD application. CAD, you know CAD, drawing inside the computer, like Fandango. Also, we can use Python in embedded application, embedded system, because Python is based on C, which means that it can be used to create embedded C software for embedded applications such as Raspberry Pi. So Raspberry Pi using Python for embedded application or embedded system. Okay. All these we can use Python. Okay. So we can use Python in everywhere, everything. Okay. So we summarize the chapter number 1 for general information, general ideas. Okay. Any question on that?
Doctor, which application is used the most for Python?
حسب شو بدك. depend انت شو وين رايح. شو بدك. بايثون بيستعمل بكل المجالات. بايثون فينا نستعمله بكل المجالات. مثل السي، مثل السي بلس بلس، مثل الجافا، مثل غيره، مثل فاكشنال، مثل ليست، مثل البرولوج او غيره. حتى بيستعمل مثل ASP.NET او PHP. بيستعمل بالجافا سكريبت. فينا بايثون نعمل كود بالجافا سكريبت بقلبه. اوكي. فمثل الجافا سكريبت بالويب، ويب ابلكيشن. فالبايثون بيستعمل محل ما بدك كيف ما بدك، بس كله بقلبه الاف من الفانكشنز واللايبريز. اوكي. ليتر اون حنتعرف على 20 وحده يمكن او 25 وحده بس، يعني ما فينا ناخذ كل شيء بايثون. هذا الكورس هو بيزكس عن البايثون. اوكي. ما فينا ناخذ everything on Python. Okay. So we'll learn only the basics of Python and some small application using GUI. Okay, this course. You need a lot of courses to learn everything on Python, but I will give you some links in Python, some useful links. If you want to be professional in Python, just read them and you will understand them, because you will get a basics, then you can be professional later. And any programming language, not Python only, any programming language, C, C++, Java, Python, ASP.NET, and PHP, other, any programming language, if you want to be professional, you need to practice, not learning. Learning and practice. Learning without practice in any programming language is nothing. Okay. In any programming language, you need to learn and practice. You need to create your own codes, your own syntax. Okay. In any programming language, not only Python. Okay. Do you have any question? Hi.
لا لا دكتور.
لا دكتور.
Okay.